My name is Allison Gearing-Klein, and I'm on the product marketing team for rendering in Autodesk A360. I'd like to welcome you to our Rendering in Autodesk A360 webinar series. Today we're hosting a webinar titled Learning Lighting Analysis in Revit, hosted by David Scheer, a building analysis special projects manager here at Autodesk. David Scheer is a registered architect and an expert in energy modeling and lighting simulation. A natural instructor, he frequently presents on how to use analysis tools and teaches a course in zero energy building design at Berkeley. Before we get started, I wanted to go over a few things about today's session. The webinar is scheduled for 1 hour, and we will break 3 times throughout the webinar to see if anyone has any questions. If you have questions at any point during the webinar, please type them into the chat box here, and we will try our best to answer them during these Q&A sessions. If we do not get to the questions during the session, we will make sure to follow up through email. You can write to us at rendering.community@autodesk.com. And today's presentation is being recorded, so we'll send that out to you within 48 hours. And now I'm going to turn it over to our presenter, David Scheer.
Hi, Allison. Thanks. Let me get my screen shared here. Can everyone hear me okay? All right. So I've been working, I've been managing this project to create the lighting analysis for Revit plugin over the last few months. We've released that a couple months ago, and I'd like to show you what we've created, what the concept is behind it, and walk you through the workflow for doing some typical daylighting analysis workflows, particularly accomplishing the LEED version 3 and version 4 daylighting credit. So this tool is really focused on architects. We feel that more analysis needs to be done to facilitate better buildings and take advantage of the known benefits of daylighting. A better quality environment, higher student scores in schools, even the point of higher purchasing rates in shopping centers that are daylit. And there's just not enough specialists available to be able to do the daylighting analysis that needs to be done to incorporate daylighting into the design process seamlessly. Giving this capability to architects is the best way to get daylighting analysis into the design process. Architects are best positioned to actually use the information if it's readily available to them. And making easier tools to do daylighting analysis also is going to make the job easier for the daylighting specialists who can hopefully spend less time modeling and wrestling with the daylighting analysis tool and more time giving recommendations to architects on how to design a better building. So I created this analogy I wanted to start out with about the difference between the daylighting analysis tool and the use of daylighting analysis information. I don't know if anybody knows what this is, but it's the inside of something that a lot of people use. And the people that use this thing don't really care what's on the inside of it or how it's made. They really care that it's done with quality, it's done on a standard, and that it's a product that they can use to, in this case, play baseball. The baseball player doesn't necessarily know how to manufacture a baseball, but he knows what to do with a baseball when he gets one that's manufactured by the proper standards. So the metaphor here is the baseball would be the daylighting analysis result. Architects would be the baseball player who need to use the daylight analysis results, but don't necessarily need to know where it comes from. So daylighting is an incredibly complex complex field. Daylighting, the way daylighting interacts with a building depends on location and time, the source of the lighting, the distribution of the light, contrast and human reaction factors, and just perception and preference. So there are a lot of things that go into determining the daylighting quality and the daylighting performance, and really what is good and what is bad in daylighting. And on top of that, modeling daylighting is very complex. Here's a diagram showing the process of taking a Revit model, going into Radiance, and running a simulation. Here's step 46 in a 64-step simplified process of running an analysis in DaySim. This is the input render options in Autodesk 3D Studio Max, where daylighting can be done. Very, very complex, and these are things that architects, it doesn't really add to the architect's design process. So what we're trying to do with the lighting analysis plugin is to create, be able to incorporate valid and useful analysis into the architect's design process. So we're looking for consistent, valid, and useful results, the analysis process to be integrated directly into the design process, making sure we're using the same model for analysis as we are for design. There's a lot of information lost in translation. There's a lot of interpretation and art to the process of creating analytical models that are separate from design models, and we want those to be the same thing. And then the results need to be incorporated into the design process feedback, just like any feedback that's given to an architect, which is for the most part visual. And all of this, as I mentioned before, is going to be helpful for increasing the productivity of the daylighting experts' work as well. So let me just move on with the demonstration here. And so, in summary, what we're trying to do with this, looking at the baseball metaphors, we've got daylighting analysis tool makers, the people who created Radiance, DIVA, the lighting analysis engine, IES engine. These are the tool makers who understand everything about the science of light. We've got the daylighting specialists who really understand a lot about the same things that the tool makers make. They have to be very sophisticated to be able to run these tools and to create an actual analytical product. And the work of the daylighting specialist needs to meet where the architects pick up. So there's this handoff between the daylighting specialist and the architect. And what our goal is really is to be able to move the work of the architects further back down the process so they can create their own daylighting analysis artifacts, overlap more with the daylighting specialists, so there can be more interactivity. For that to happen, the tools must do a better job of automating the process of creating helpers to bring the sophisticated, highly intricate settings up to a level where architects can use them. And what all this does is allow the daylighting specialists to move further up the design chain, work more in the design realm rather than the model building realm. But still, they're the ones who are going to know how to do specific and very detailed fringe case type analyses. So this is a product that I created from a sample daylighting analysis in Revit. This is our goal here was to use standard Revit platform tools, layouts, floor plans, etc. And to bring the daylighting analysis results into this working environment of the architect. Now, what we're working with here to simplify the process, not to simplify necessarily, but to narrow down the process to something measurable that we can use to give us a feedback of a yes or no, good or bad, is we need to find a metric that represents the performance of daylighting. Some typical metrics simple characteristics that are processed during a lighting analysis are illuminance. This is how much light is falling on a surface, and luminance, which is how much light is basically coming off a surface, how much light is available to the eye. So these metrics are just a way to measure the performance of daylighting. Now, if we add benchmarks to these metrics, metrics are going to be a value, 0 to 50 or something, but we don't know if 40 is good or if 30 is good. If we add a benchmark to the process, let's say 35 is our target, we know that 40 is not good enough, 30 is good enough and better. So with metrics and benchmarks, we can allow architects and others to make a decision about the goodness and fit of a design very quickly. So what we're looking at using is the illuminance value. Illuminance tells us how much light is available to be used on a surface. This is one of the most important metrics in daylighting performance. You can imagine that the reason we have light fixtures is to have light fall on the desk, so it can be useful for writing, reading, etc. If we can do that with daylighting, all the better. So these are some typical benchmarks for foot candle levels for different uses. What we are implementing for the first round on our lighting analysis tool is to use a regulatory metric that is fairly popular, which is the LEED daylighting analysis benchmark. So the LEED daylighting analysis, to qualify for the LEED credit for daylighting, there are 3 methods. Option 3, this is version for 2009. Option 3 is to take measurements with a light sensor. Now, this, as you can see, can only be done after construction. It's not very useful in the design process. So that doesn't meet our criteria of being integrated into the design process. So we'll move on to another one. Option 2 is to do a prescriptive design calculation. Now, this also just talks about window head heights, daylit area based on the geometry of the building. It's not as easy to integrate into the design process, although it can be done earlier in the design process. The option 1, the full daylight simulation, allows us to integrate the analysis results, the analysis process, directly into the design process. And coupled with BIM, we can bring the metric into the design environment and allow the analysis to start earlier. We can start doing analysis when you have a very diagrammatic, schematic design. And if that information is in a BIM model, like Revit in our case, that information can be carried throughout the design process, from schematic design concept all the way through to construction documents and beyond. So this just fits our general approach that we've been using for a while in Revit with analysis, is to integrate the analysis results into the Revit model, into the Revit process. So solar analysis, lighting analysis, energy analysis, these are all things that should be available in the BIM model itself. So let me talk really quickly about what our offering is in this area. It's called the Lighting Analysis for Revit plugin. I'll talk about a little bit more about what that is and how to download it in a minute, but let's look at the basic concept. So the idea is that we want to provide, a fully functional baseball daylighting analysis to the architects. We're providing it with on the surface, a very simplified interface that allows users to move very quickly through the daylighting analysis and results generation process. And I'll show you as we go on how we can peel back the layers of that baseball to get to deeper settings in the process. But on the surface, we want this to be a very simple process. So 2 buttons, run analysis and generate results with a fairly simple interface that allows allows you to set the analysis type, and then a couple parameters that will help you define the cost of your analysis. Bring those results directly back into the Revit model, show those results on the model itself. So these become a design artifact and something that is spatially generative. And use typical Revit tools, in this case the room objects, to define the regularly occupied spaces for lead. And bringing those analysis results and being able to navigate through different results, in this case for 9 a.m. and 3 p.m. To see the overall results on the design. And then giving both high-level overall summary results. In this case, we've got a final results view for whether you're going to pass or fail your lead analysis. And then schedules that give more detailed results. Here at the floor-by-floor level, and then down at the room level, very detailed results for every single room in your model. And with these artifacts, we can create layouts and reports, and what I'll show you in the live demo actually automatically generate the submittal documentation for the lead version 3 and version 4 credit. So I'm going to stop here for a second, see if there's any questions about our general approach, and then after that I'll go into a live demo of the tool. Stephanie, are there any questions?
Yeah, we have a lot of great questions on the line, David. Just to get us started, this plugin, is it localized? Can you use any climate zone or any weather station?
Great question. I'll actually address this during the live demo, but the short answer is that it uses your Revit project location, which is a setting that you do in your Revit model, and it'll automatically look up the appropriate weather data and choose the appropriate day and time out of that data. So the process is automated as long as you set your location.
Great. And piggybacking on that question, can users set the date and time beyond the fall equinox?
Yeah, right now the tool is set up for the lead analyses, the option 2 for V4 and the option 1 for V3, and this requires analysis for September 21st and March 21st at 9 and 3. So those are the times that we've locked in right now. I'm going to show you a little bit later how to do custom Illuminance renderings using the cloud rendering tool in Revit. But for the results being passed back into Revit with lighting analysis, we're using just the 9 and 3 p.m. right now. But your suggestions are what drive our development, so we've heard this many times, and we're definitely taking that to heart and put that on our roadmap.
Great. What other metrics, daylight factor, daylight autonomy, solar analysis, what else can we look at with these plugins?
Yeah, solar analysis is currently available in Vasari, which uses the mass objects in Revit type files, Revit files, and the lighting analysis. I'll show you the way you can generate Illuminance renderings for any time, any day. And we've got a number of different sky models, including daylight factor sky and some standard skies. The lighting analysis tool, which is kind of the most advanced, really, is locked into using the times and dates for the lead analysis and uses the Perez sky model.
All right. I know we're probably going to cover this later in the call, but questions about cost, and also if you could maybe touch on student versions and what that looks like.
Sure. Yeah. Why don't I move on to the live demo, and I'll probably cover a lot of those, and we'll see how many questions are left after that.
Sounds great.
But since this webinar is presented under the title of the rendering, the cloud rendering tool, I wanted to touch on the relationship quickly with the cloud rendering tool in Revit. This is a tool that will do renderings on a cloud service, so not take up your computer resources, work very quickly, do many renderings in parallel, many benefits to it. It's a very, very popular tool, and the engine behind that tool is very physically accurate, and that's why we're using that engine for behind the lighting analysis tool as well. So just quickly show you where that is. I'll show you a little more about this later. On the View menu, the Render in Cloud will take any 3D view, bring up the dialog. You can choose an output type. By default is a still image, but if you select the output type to be Illuminance, instead of generating a visual rendering, it will generate a rendering of the Illuminance values on all the surfaces that are visible in the view. And you can see that the location, time, sky model, and legend settings are all very open. You can set any time of day, and I'll show you when we get to Revit a little more of the options available there. So back to the lighting analysis tool before I open Revit. Again, very, very simple front end, 2 buttons. First step is to run the analysis. Set up some very simple settings in the Run Analysis UI. Basically, setting the analysis type, which we have 2 types right now, Lead V4 and Lead V3. All the other settings are either automated or they are intended to define your level of quality and scope of the analysis, which will help control your costs. We do have, while I'm on costs, the plugin itself is free, and it's these renderings. The service behind it is available if you just have a 360 login. So, that's all free, very easy to get. Any high quality, which is a point every 1 foot, every high quality Illuminance rendering is free for an area less than 3,000 square feet, and above 3,000 square feet, it's 1 cloud credit per 3,000 square feet. For lower resolution, which is a point every 4 feet, it's free for an area of 25,000 square feet, and then it's 1 cloud credit per 12,500 square feet after that. So we've set it up so that everyone should be able to do free analyses, to get comfortable with the tool, to make sure that their glazing settings are correct, all their model is set up correctly before they have to spend money on the tool. So you should be able to either build a small model or just run part of your model for free. Sorry, while I'm in this dialog, the environment settings, this is the location there you see is chosen from your Revit project location. And then the date and time are set for the analysis type, and we automatically look up the solar values. You can see there that the weather file values that we're using are listed. So if you want to go into another tool like the Rendering Illuminance tool, or even into an advanced tool like Radiance, you can use these values to get similar results. The Illuminance thresholds are automatically set for the analysis type. In this case, Lead V4 requires a 300 to 3,000 lux threshold range. And down at the bottom are the cloud credits, how many are available on your account and how many are required for this type of analysis. Just one point about cloud credits. Cloud credits are purchased through subscription, but even if you don't have a subscription, you can run analyses so long as you're in the free range at the lower high resolution. So you'll see there, if you have scoped your model and your resolution quality properly, you'll see that the required cloud credits will be 0. and then anybody could run those. And for students, it's wide open. Everything is free for student licenses. Now the second part of the process is to generate results. After we run the analysis, the results are automatically downloaded to your Revit model. So once you purchase those results, once you committed to run the analysis and purchase those results, either free or cloud credits, those results are saved with your Revit model. So they're yours. They're not going anywhere, and you can work with them and generate and regenerate them in a number of different ways. And the results are presented in a simplified dialog, in a detailed schedule, and in the Revit model itself. So I'm going to switch to Revit here and show you the process on an actual model. Now, the way I want to look at how this integrates really into the larger process of energy analysis in Revit, because we've got some pretty powerful tools now for on the analysis toolbar. In the energy analysis tools, normally the way I would start out at any point in the process is to just run an energy simulation on the existing model. Running an energy simulation will generate appropriate energy model geometry and defaults for your building location and your building type, and return results in the result to compare dialog in the Revit environment. So the results to compare are where you can see your results. Let me pull those up here. And these results are delivered back to results to compare as part of Revit. Now, we've got this old summary results here, which are not as useful as they could be for something like understanding what to do next with your daylighting analysis. So we've introduced a new dashboard lately, Project Salon, where we automatically run a whole slew of runs. In this case, and for this dashboard here, about 50 runs that really profile how sensitive your building is to different settings. So in this case, since we're working on daylighting, we need to understand, well, how important is daylighting to the performance of my building, especially compared to other factors. So what I'm going to be looking at is the lighting controls parameter here in this particular setting. I'm going to turn off the plug loads just to highlight the lighting controls. I can see here that the lighting controls annually have $5,500 payback just in energy costs. So so daylighting is a fairly important factor in this particular building. Here you can see the lighting efficiency itself. If we can really reduce the lighting loads, we're doing a lot to increase the efficiency of the building. So having seen that daylighting is important, it's worth spending some time on. I'd go into my lighting analysis toolbar, click the Run Analysis. And what it's first doing is looking at your project location, and it's making a call to Green Building Studio's climate server. And it's looking for the data from our server. We've got a grid of about a 14-kilometer grid across the world with climate data. So most areas of the world are covered. So this is the cloud service. So I'm signing into my Autodesk account. And now the climate data has been delivered, and I get this initial dialog, which is just a help screen that tells us what we need to do to set up our project properly. These are pretty good idea to look down this and look down at each of these things in detail. We'll go over it very quickly for the time being, then I'll go back to the deeper settings after that. So it's very important to set location. We find that we've got a lot of people, their models are running in Boston, which is our default location. So a lot of people forget to set their building location. So be sure to set and manage, set your building location. Defining your service and glazing materials properly. We've got a link to the help documentation here that'll show you how to set those up. This is probably the most complicated part of our process right now. We're developing tools to make that easier, but the help documentation is very clear on how to do that. The analysis planes that we're running the analysis on, the points that we're running the analysis on, by lead requirements, it's a plane of points with at least a 5-foot grid resolution, and the point should be located 30 inches above the floor surface or on a work plane. So we basically generate a grid of points at a 1-foot resolution, 30 inches above all of the floor objects in your model. So you may see if you're using floor objects for areas outside your building, it's a good idea to put those on a level that you don't run the analysis on. So any floor plane will generate analysis points. The 3D view properties in the lighting analysis view are what are used to define what is included in your lighting analysis model, and I'll show you that after we generate the results here. And then rooms, it's not actually required to define architectural rooms in your model, but if you do define rooms, rooms are used to define lead regularly occupied spaces. It's also used to summarize the data in the rooms table about how your performance is on a room-by-room basis. And rooms are also required to generate the proper results for the lead submittal. In run analysis, I talked about these, setting the levels for which floors you want to analyze, setting the resolution for the quality, mostly defining cost. And then each time you make a change in either of these, there's a check price button, and you can see how much your analysis is going to cost. Now on the cost, we don't charge your account until we've successfully completed the analysis and returned the results to your computer. So even if you tell it to go ahead and run an analysis, we don't charge you until we've actually completed that, we've actually accomplished that request by you. So sometimes the system will go down or results won't be generated properly, and we don't charge you for those results. And I'll go through the generate results page after we get results back. Oh, I actually have signed into the wrong server here, unfortunately. This is something that happens sometimes when we're working from a development environment that we've got settings that work differently than what you would see. So now I'm logged in. So I'm going to move on to, let me actually go ahead and kick off this analysis so we can just show you how long it takes to run. It's one thing that we're very proud of with this analysis engine is this is a proprietary analysis engine that we've created to be very fast and very predictable, and to do the simplifications based on algorithms that that control the quality rather than users having to guess what is needed for each particular environment. So the analysis engine is very, very fast. For instance, an analysis that would take a couple hours in a tool like Radiance might take 5 or 10 minutes with the lighting analysis engine. So I'm just going to go ahead and kick off an analysis here. In this case, this whole building will cost me 18 credits to do a high-resolution rendering. If I wanted to do a low-resolution analysis for just one level, I can check my price on that. And you can see that that's actually free if I want to do one level at a time. So I'll go ahead and do a high resolution for all floors. and I'll start the analysis. What happens next is the model is quickly translated into a format that can be read by the analysis engine. This just takes a few seconds. All the materials, geometry, all the details of your Revit model are uploaded to the cloud. There's a short time period where the model is uploading, and during that time, if you close the project, you'll lose connection to the data. But it's a very, very fast process. Now the model is totally uploaded, and you're free to continue doing your work in Revit, and now the model is in the cloud, and the rendering is happening, the analysis is happening in the cloud. So while this is going, I'm going to switch to another model that I've already gotten results for. And let's look at this is running the 2009 lead. Now I've already gotten results back, and I'm going to go to the second phase, which is the generate results. Now the generate results button goes through a few processes to parsing the data that is already returned on your computer. All the raw data points are on the computer for the bounding boxes of your floors. We're clipping them now for the boundaries of your floor plate, and also parsing them out into the different room objects so we can calculate the performance of the points in each of the room objects. And this process takes a few minutes. On a large model, I've seen this take up to about 4 or 5 minutes. This model, you can see it took about 20 seconds to parse all those results. The first screen we get, this is a little more advanced screen than what we saw in the PowerPoint. We see that this building passes LEED 2009, and it shows why. We've got an 89% passing threshold for the 9 a.m. time and 88% for the 3 p.m. time. So both of our times are above 75%, so we qualify for the LEED credit. And this shows the details of the data that we use for those 2 times in case you want to do some deeper analysis. Now, in addition to generating those summary results, we've got results that are actually generated on the model. So for in a 3D view, results are generated directly on the 3D model, and I can do things like let's cut a section of this. Let's see. I'm going to go to another view here where I've got a section cut. I'll generate results again. Now, the second time you generate results on the model, it has already parsed the results for the rooms and the floors. So the time that it takes to generate results is mostly drawing the point values on the AVF surfaces in the model. So you'll see those results appear in a few seconds here. And there's our summary screen, and the results are generated on the model. So now I can do things. This is where this becomes a design tool as well as an analysis tool. I can see, exactly which rooms are performing poorly. In this case, the scale is set to red is bad, yellow is too much light, anywhere in between is a gradient. If I click on the analysis surface, I can choose between the 9 a.m. view and the 3 p.m. view. So if I'm performing better or worse during one of these times, I can look into that view itself and see what areas I can improve my performance. So in this case, my main liabilities are 3 p.m. I'm seeing that I'm getting a lot of direct sun right at the perimeter. Now this may really disturb workers that have desks at the perimeter of the building, so this might tell me that I should put in some better shading devices, maybe some roller shades. So you can see that by getting the results in the model, I'm really getting information back to me that's going to influence my design. The other artifacts that are defined are the lighting analysis floor plans. So you can see in the 3D view all of the areas that have analysis done on them show results. In the floor plans, we only show results for the LEED regularly occupied spaces. And this is so you can generate your LEED submittal from the floor plans. And you can also only focus on the rooms that are actually being considered for the analysis for your LEED points. The other artifact that is generated are schedules. We have both a floor schedule, which gives us the summary data for both the 3 p.m. and the 9 a.m. in both percentage and area for the above, below, and within the threshold, floor by floor, and then the room by room schedule. Now this is where you can do some additional work. Here you can see that we've included both an include in daylighting and an automated shades column. If you have automated shades, LEED allows you to ignore the upper threshold. So those areas of direct sun would be considered to be blocked by automated shades, and I could count those in my LEED performance. The include in daylighting column is basically defining my LEED regularly occupied spaces. So if I go through and change and add automated shades to a couple of rooms here, it gives me a warning that my summary results are now out of date, so I should regenerate results. And then I can regenerate the results on my existing points that I've analyzed, and it'll give me new values considering that I have automated shades. I can also add or subtract rooms to the include in daylighting, and I don't have to rerun an analysis because we've already analyzed all the spaces. By changing the include in daylighting designation, we're just defining what rooms are included in the LEED calculation. Now, this spreadsheet, this schedule was created to generate to give you all the results that you need to put into your LEED spreadsheet. Here, this is the spreadsheet that they require you to fill out, transferring the data from each of the spaces, each of the rooms onto the spreadsheet. So that's a pretty tedious process. So we've also created another tool called the LEED Credit Manager for Revit that automates the process of filling out that spreadsheet. Now I've got a video for that to show how that process works. So in this case, it's showing that this LEED Credit Manager tool works in coordination with the lighting analysis tool. After you've generated results, you can go to the LEED Revit Credit Manager tool, click the interface, select your option 1 daylighting credit, and the results from that room schedule are going to be loaded into the credit manager, and it'll generate all the artifacts you need to submit to LEED for the daylighting credit. This interface allows you to make minor modifications at the end. It generates your floor plan views that are required. You can see in this case it's slightly different rooms are selected for the LEED regularly occupied. And then it's going to actually export the schedules and fill out this spreadsheet for you. So you can see here's the same spreadsheet. It's automatically filled out with all the information from your room schedule. And you can simply submit that with your LEED documentation. That should be about everything you need. The credit manager also has methodology to do the other LEED compliance method as well. So here's the floor plans that it generates. And that plugin is currently available on the Autodesk Labs site, so labs.autodesk.com, and just look for Revit Credit Manager for LEED. And that's a plugin, I believe it's only for 2014 right now. So let me stop for a couple more minutes of questions, and we're kind of running out of time. But I'd like to cover a few more questions and show you a couple more things you can do in the 3D view before we finish up here. Actually, I'm sorry. Sorry, Stephanie. Before I go on to questions, I wanted to point out the other thing. I mentioned that the lighting analysis 3D view is what determines what is included in our analysis view. So we generate this view automatically, and we do things automatically to help you out, like we turn off furniture and other temporary interior partitions. We automatically set the phase to a show complete. So and we set the design options to default. We remove section cuts and other things that would create a bad analysis model. All of these things can be overridden with some config settings, which I'll show you a little later. But we try to do things as automated as possible, but allow you to set them manually if you need to. So if you ever need to understand exactly what's included in your analysis, well, so you can see here our analysis that came back. I think we kicked that off about a little less than 10 minutes ago. So it took about 10 minutes to do a detailed analysis on this whole building. Now I'm just going to accept that, and it's going to download those results to my model. So if you ever want to understand exactly the geometry, it's basically what you see is what you get. You can look at this model and understand that this is what is being analyzed in your daylighting analysis. Okay, Stephanie, any questions?
All right, yeah, so we have a lot of great questions on the line. I think people seeing the tool kind of really generated their interest. So I'm going to try to start with general questions and maybe get more specific.
Okay.
So one general question we had, does this work for Revit 2014 and 2015? And if so, is there a difference?
Yeah, the lighting analysis for Revit tool is available for both 2014 and 2015. There's no difference between the two tools right now. And that is available for download either through the lighting analysis for Revit product page. If you just search for lighting analysis for Revit, that'll come up your first search item in Google, or through the Autodesk Exchange store.
Great. So you kind of mentioned, high resolution, low resolution. What's really the difference between using the two, and how is that going to impact the results you're getting and the accuracy?
Oh, great question. So this view that I'm showing right now shows basically a gradient view that's generated by my grid points. If I go into my analysis display settings here, I can see that there's an analysis display style for each of the floors. Right now, I'm just going to focus on the third floor, and I'm going to change my display style. We've provided a bunch of different styles here. I'm on a standard result style. I'm going to change it to a point style and show you the raw points that are used to generate this information. So now the AVF, or Analysis Visualization Framework, is regenerating the rendering of these points. It takes a couple of minutes. The points are a little bit heavier for the tool to handle because there's so many numbers of points. So basically, this is my video card. It takes a long time to render this. So you can see that now you can actually see the grid of points. It's very dense. My point objects are actually a little bit too large to be able to distinguish between the points. But you can see here there's 5 points in this first 5 feet of the wall. So if I generate a high resolution analysis, I have a point every 5 feet. A low resolution analysis, I have a point every, a high resolution is a point every 1 foot. A low resolution is a point every 6 feet. So you're just not going to get as good a resolution. But a low resolution analysis is really good for setting up your model because you're going to get some relevant points in each of your zones, and you're going to be able to understand if you've got some anomalous settings on your windows or something.
All right. And do these calculations consider context, for example, trees surrounding buildings?
Yeah, one really powerful characteristic of the rendering engine is that you can submit a model. We had one customer give us a model where it had the entire city of New Orleans, and they had one little office model, one-story office model that way in the corner, and that's the only thing that they ran the analysis on. In most analysis tools, you really got to get rid of that geometry because all that geometry takes a long time to process. The rendering engine will look at the points that you're trying to analyze and parse out the parts of your model that are actually needed to be included in the simulation. So yes, you can definitely include a model with full context, from InfraWorks or wherever, and trees, and it's all considered in the daylighting analysis.
All right, so we have 5 minutes left. I don't know, was there anything else you wanted to show, David, or should we keep going with questions?
Well, let me just touch on a couple things really quickly. I showed you the analysis display settings. These are, you can make up your own styles and generate all kinds of different types of views. So even though we do an analysis for lead and we set up our style to highlight the thresholds, if you want to do something that looks at a generic results, for instance, here's a typical radiance style, just showing a range from 0 to 100 foot candles. Let me generate that. So, it doesn't. Although my schedules are still generating results for the lead daylighting credit, this actually becomes a very useful tool to look at the performance for other thresholds for other uses. The other thing is just show you the rendering cloud settings. This we generally say is for advanced users who want to do some more advanced renderings. Again, it's a really simple 3-step process. To run analyses for other times of the year, we'll select the, here I've set up a couple models here as a 3D plan view. I'm going to choose my Illuminance setting. When I choose the Illuminance setting, I can choose much more detailed analysis settings, so a particular date and time, or I can use the date that's set in that view. The sky model is where I can define, for instance, CIE standard overcast sky, a daylight factor sky, or the Perez model, which is kind of the industry standard sky model, and I can put in my radiation values, and then generate any sort of legends I want. And what that'll give me is, let's see if I can get that up here. Let me actually switch to another model where I've done this rendering. This is another model where I've run a rendering in through Render in the Cloud, and I could go to my render gallery. And so here's, this is the analysis that I generated through the Render in Cloud settings. So you can see similar sort of results. The limitation here is that it's a still image, and the results are not shown back in my Revit model, but the benefit is that I can do any time of year. And I can also include electric lights as well as daylighting. So I think that highlights all the main points. Are there one or two more questions before we close it up?
Yeah, so I just want to bring, there's been a lot of great suggestions, essentially feature requests in the question. So what's a way that these users can kind of feel heard and let us know what they would like to see to better this tool?
That is great. I'm so glad that came up. So we have a very good forum, BPA forum. Stephanie, you can tell them the address of that?
Yep. I will send it out in the chat.
Okay, great. So yeah, the BPA forum is really the place where me, I'm a product manager and talk to the developers and help decide what we work on, every week. So, me and all the other people who are in those roles and making decisions about what we build, we look at those messages every time they come in. Extremely important to us. So interact in the forum. That's a great place to go. I'll just leave it at that, actually. The forum would be the place to go. We do have a help email, which is referenced in other places, but the forum is really the place to go, and that'll send the emails out to all the stakeholders. And we're really interested in what you guys want. That's what drives our decision making.
Great, and I'll mention I sent out the link in the chat, and you'll get it in email. But if you scroll down to that idea station part, that's really where the best that's where we look for new ideas. So one last question that kind of seemed to be a common theme was material values. Just maybe can you give a little bit of overview of how this plugin is thinking about and considering materials you either set in Revit or you're maybe modifying on your own?
Yeah, that's really one of the most critical parts of this process here. And the help documentation, I'm going to refer you to that in the short term because we're running out of time. But the help documentation, which is linked, which is available through the F1 help. So if you hover over the analysis buttons and press F1, it'll take you to this page. This has 4 main sections: general settings for daylighting analysis, the lighting analysis for Revit plugin, and then the rendering Illuminance workflows, which I just showed you, and then some general workflows more talking about the lead workflow here. So for setting materials, in the Revit settings, the surface and glazing material settings are what we're interested in. I'll just show you a couple things. The way materials are defined are simply by either selecting the material from the object editor or go to the materials editor itself. We define the glazing, transparency, and the opaque material reflectivity through the appearance tab through RGB values. Now, we know this is a little bit complex. It's an artifact of how the rendering engine it uses materials, and we're working on improvements to that. But meanwhile, the RGB values in the appearance tab are where you're going to set the reflectivity. And what we've done to make it easier for you is to provide a table of values where, to use the table, you would look up the modeled thickness of your pane of glass in this case. Most of the time it's 1 inch or 25 millimeters. You look for the T-vis, the visible transmittance of the glass you want to use, and you find the value here, 109. You would just put 109, 109, 109 in the color range here. And it's a similar thing for the opaque material. So please give us a read on this. This is an area where we're really interested in doing improvements. And we'd love to hear your feedback about how you would like to define materials in Revit for daylighting analysis.
Thanks, David. I'm just going to say a couple more words closing out and just switch my screen over here. Thanks again for that thorough presentation, and thanks to everyone who attended. If you have any more follow-up questions, please write to us again at the rendering.community@autodesk.com address. For more resources, you can go to the Lighting Analysis for Revit page, and then to learn more about cloud rendering, you can go to our Rendering in Autodesk A360 page. For any of you who use Navisworks, we're having a webinar next week about how to use cloud rendering in Navisworks, so we'll be sending out that link in our follow-up email today along with the webinar recording. And until next time.